Hello, let's start today's LeetCode problem. Let's try to solve it in 20 minutes. 20 minutes, or let's not take more than that. So, without any ado, let's get started. So, what's the question? Rotate function. You are given an integer array nums of length n. Assume array k to be array obtained by rotating the nums by k positions clockwise. We define the rotation function f on nums as follows. So this is the function. Return the maximum value of f0 to fn minus 1. The test case are generated so that the answer fits in 32-bit integer. Okay, so by reading this, so far I have understood nothing. Like, who the fuck is outside? Anyways, um, yeah, I have not understood anything, so I need to go through examples. So we have, let's say, this array and output is 26. Why is that? So 0 into 4, 1 into 3 um, is 25. This is 16. This is 23. And this is 26. Okay, so makes sense. So we need to multiply the number by the index. So this is without any rotation. We get 4 into 0, 1 into 3, 2 into 2, and 6 into 3. By looking at this, it's 25, and the answer here is 26. That's because we try to minimize the impact by multiplying with 0 and try to get maximum value by putting the maximum number at towards the end. So in the end, this array rotated uh, was looking like something like this: 3, 2, 6, and 4. This gave us 26. Now if I have to think, uh, there is a very simple brute force solution here. Just do what they are asking. Right, so just start with this and multiply each index by 0, starting here, then starting here 0, then starting here 0, starting here 0, and um, to get that index we do something like size the index mod size or something like this. So that should be good, I think. Hmm. So what next? So I need to find a way um, to minimize this brute force and to find exact position that would give me the result. Let's see the constraints. So it's 10 raised to 5, so any brute force solution of n squared won't work ideally. Yeah, so so just to think out loud, there are two situations, right? First is index 0. So any number multiplied by 0 will be 0, and then um, what the hell? Max num in the array, which could be anything, let's say 20, but if you move this towards the end, which is like array of length size 5, so max index is 4, so this value is gonna yield the uh, most what you call maximum number. Yeah, so based on these two values I need to find, based on these two I need to figure out how can I maximize the value. uh, Nothing is coming to my mind right now, and someone out of the door is making some noises, so that's fucking irritating, but that's fine. Let's think. mm, yeah, how can I know which one to pick? And if I know that, then I don't need to do rotations and anything. Is there some relation between rotations? After this, there's this, and then there is this. So let's see. Uh, what I'm going to do is I am going to say this array, right? So this is the array. So what I'm saying is, at first position, what is the max value I can get? So I can get 0 into 0, um, 1 into 3, 1 into 6. So I can get 6 here, I can get 6 here, I can get 6 here. No, I can get 12 here and I can get 18 here. Now why? Because these will be 0, 1, 2, 3 indexes, and multiply by 6 maximum number, which is 6, which gives us 0. At 1 it gives 6, 12, 18. But even this is not enough, because uh, because in this first example case we saw that this was the winner, where uh, yeah, this was the winner where 6 was at number 2 position and not 1. Yeah, that's because this multiplication was leading to 0, which was a bigger number. Yeah, I don't think I have any other solution than brute force, and I think brute force won't work. But as there is no time, we have 10 minutes left, I'm just gonna go with the brute force. Now let's think about the solution for brute force approach. Um, Again, so we have this array. That's good. Now we need to multiply starting from 0 here. So 0, then 1, then 2, then 3. That's fine. And we check the max so far. Now this value should become 1. So it should be 1, 2, 3, and 0 here. That's how it should be. Okay. So to do this, I can do index plus 1 uh, mod size. So this is, so the first iteration should look like index plus 1, which is 1 divided by mod by 4, which is 1. So everything is fine. So when this index is 3 plus 1 is 4, mod 4, which gives us 0. Okay, so I think this is fine. um, yeah. So how do I do this? So where result is equal to 0, let's say, um, and then for I in nums dot indices, or I could do um, so how many times I need to do this? So this is 0, 1, 2, 3. Okay, so I think I can do something like x in nums dot indices. So this is the delta. So we go from 1 to n, and then for each index in nums dot indices, what we do is effective, just gonna, for simplicity, effective index is equal to index plus x, mod nums dot size, right? And then um, so this is val current product is equal to 1, and current product into equal to um, nums of effective index. mm, no, nums of index into effective index. Okay, so that's the current product, so we get it here, and after that we check if we can just do max as well. So val, so result is equal to max of result or current product, and then return result. So let's see quickly a dry run if it works. So we have result declared, that's fine. We have x, which is like a delta going from 1 to 1. um, I think it should be less than, but let's see. Going from 0 to um, n minus 1, let's say, and then product we declare it here. So this should be var. This is fine. We are updating it. So this is the important part. So now I is 0. If we take this example, x is 0. So effective index is 0 plus 0, which is 0 into mod size, which is 0, and then nums of I, which is 0 into effective index 0. So this will be 0. Okay, so that's not how it's gonna work. So this should be like this, um, plus, and this. Okay, so that's a good thing, we found a bug. So we go 4 into 0, we add 0, then we go I is 1, x is still 0, so 1 mod size is 1, so nums of I is 1, which is 3, and then effective index is 1, so 1 into 3 is 3, so that's 3. I think this should work. Let's see. Yeah, at least our brute force solution is correct. That's a good thing. I get a tap on my back, but I still don't have any idea how to solve this um, more efficiently. So let's see if this passes. I don't think so, but then we can go through the solutions and try to find it. Yeah, as expected, we got the TLE. So looking at the solutions now, O of n solution is possible. In this case, it's O of n square. Let's see how. The idea is to compute fi1 using f of I, where f of I plus 1 is equal to I plus sum of nums minus length. Oh, so this is basically some kind of a math here. Okay, got it. So there is this and this. It's fine. Anatoly is saying his code is faster, 2 cycles. What is he doing? I don't know. So this is length, full sum. Okay. Yeah, so there is some kind of a two pass solution here, I think. With my level at this point, I have no idea how this works. So I might need to still solve a lot of problems. But at least I was able to come up with a brute force solution, and I'm fine with that for now. Um, yeah, so that's it for today. Thank you so much and have a great day.